Sorry, I'm looking at the chat now. All right, I'll cut all this out. Crap. Retraice 111 for Monday, January 9th, 2023. And this is, we're talking about the gorilla problem, and it's based on some notes added after Retraice 109. And we were in the context of talking about predicting default doom and all the different things that could lead to default doom. The gorilla problem falls under the superintelligence category. So that's where this is coming from. I felt like I needed to add that the quote that I'm about to read to you from Russell and Norvig to Re111, and now let's talk about it here today. Okay, so the gorilla problem is this: about 7 million years ago, a now extinct primate evolved with one branch leading to gorillas and one to humans. Today, the gorillas are not too happy about the human branch. They have essentially no control over their future. If this is the result of success in creating superhuman AI, that humans cede control over their future, then perhaps we should stop work on AI, and as a corollary, give up the benefits it might bring. This is the essence of Turing's warning. It is not obvious that we can control machines that are more intelligent than us. And we might add that there are fates worse than death and being trapped in a zoo. Use your imagination. Okay, so most of the book they say it reflects work. Most of the body of AIMA 4E reflects work done with the assumption of the standard model, which is a standard model of putting the purpose into the machine with certainty. And the problem with the standard model, so the standard model says an AI system is good when that system does what it's told. And the problem is that it's hard to tell a system what we really want it to do. And the solution then is the human compatible model, which is putting uncertainty in the purpose. And that has design implications. So on page 34, they talk about which chapters deal with the design implications. Chapter 16, a machine's incentive to allow itself to be shut off follows directly from uncertainty about the human objective put into the machine. Chapter 18 describes assistance games, which are the mathematics of humans and machines working together. Chapter 22 talks about inverse reinforcement learning and which is how humans and machines which is how machines can learn about human preferences by observing their choices. And then Chapter 27 describes some of the problems that become obvious. For example, our choices depend on preferences that are hard to invert for that inverse reinforcement learning. And then the second problem they mention is that our preferences vary over time and from person to person. So you might not want tomorrow what you want today, and what you want today might not be what someone else wants. And those things might be in conflict. What does the machine do? Depends on who's controlling the machine. That's the gorilla problem. The human problem is, how do we ensure that AI engineers don't use the dangerous model, the dangerous standard model? How do we ensure that the human compatible model is what every AI engineer, every time they build an AI, uses? And then following that, if we could solve that, then we'd have to solve the problem of AI technology becoming easier and easier to use and more public, so that non-AI engineers can use it. And how do we ensure that those people don't use the standard model, like people like us? I could go use a public API for one of the GPTs, or I could go use a large language model from someone else, or this and that if it's made public to me, if it's open sourced. Okay, and what do you do if I use the non-standard model and that thing is sufficiently powerful? Which raises the broader question of, how do we ensure that no one does any particular thing? Is there any way? I mean, this is an Earth of 8 billion people. How are we ever going to ensure? And there are answers to this, but you might not like them. That any person doesn't do or does do any one particular thing. So the human compatible model indicates that the artificial flight version of AI, which is to say, the good version, what we want is like the equivalent of artificial flight, is possible. The human compatible and their design implications indicate that it's possible. It does not indicate that it's probable, and that's crucially important. And even to make it probable, if we could make the human compatible model probable, it still wouldn't make the incompatible, the standard model version of artificial intelligence, improbable. So the way that I put this here is that nuclear power plants don't make nuclear weapons less probable. Okay, nuclear power plants is what we want. Nuclear weapons, kind of we want those two for defense. But really, like the existential risk of those things, we could all do without that, right? But nuclear power plants have nothing to do with nuclear weapons in that sense, in a sense of decreasing the probability of the use of nuclear weapons. And so these are the sorts of problems that are taken up by Nick Bostrom, 2011 and 2019. So information hazards, a typology of potential harms from knowledge, and then the vulnerable world hypothesis. Okay, that's it for Re111 for January 9th, 2023. Signing off.